To load a program on the VF1 mill, we're going to select List Program. This automatically brings up all the programs that are in memory. Using the cursor, we can cursor down and select our part. Once we've highlighted the part we want to use, we can press Select Program. You're going to notice that that part displays in the memory side on the left-hand side of the screen. If you're using a USB device, you would simply scroll up, scroll over to USB device, press down on the cursor, and the list of files located on your USB device would appear. The USB is located on the right-hand side of the pendant right here. Once you've loaded the program into memory, and you've done all of your touch-offs, your part G54 offsets, you've done your tool touch-offs, you've verified all the tools in the spindle are correct for that application and in the right tool location, then we can go to the memory mode. Once we've loaded our program, we've done our G54 offsets, our tooling offsets, and verified that all the tools are in the right locations. Then we can go through a test of the program without actually cycling the process, just to make sure that our program is running as it should. So there's a couple ways that we can do that. The first way I'm going to show you is the graphical way. So under memory, we're going to be in memory mode. We have our part that's loaded under the memory side. We're going to use the Settings Graphics button. We're going to press that twice. You notice this graphics display shows up here. At this point, when graphics is on, when I hit the cycle start button, the mill is not going to move. It's just going to show a graphical representation of what's happening. So pressing cycle start, you can see that the G-code starts running through and there's a graphical representation of what's happening on the screen. This is great to look at to make sure that it is the part that you're currently looking for, you're supposed to be running. It also gives you the opportunity to make sure that there's no excessive movements that might cause your machine to crash. So this happens to be a rather large file, so using the graphical display is a good option for you. If you have a smaller file, you can use something called single block. So what single block is under single block, I can use this in the memory mode. I can also use this when I'm actually running the mill. Single block on only runs one line of code per push of the button. So I'm going to press the button. It's going to go line by line by line by line. And I can follow my program through and verify that it's doing everything that my G-code says it's supposed to do. Again, this is great for proofing out a part. It's also great for proofing out self-written G-code where the G-code is smaller, and we can go through it line by line and make sure that everything is working correctly. Now we can use that in the graphics mode. We can also use that when the mill is actually running as well, just to make sure that we don't have any issues. Another key component to testing out a program is when it comes to actually cycling the program, we want to make sure that we have our rapid rate set to low the first time that we run the part. So our rapid rate at 5%, you'll notice that under the rapid right here, is going to mean that our spindle is going to move slowly so that we don't have any issues. If it looks like our part is going to crash, we can have time to stop that part from crashing before we do damage to our part, to the equipment, or to the tooling. So always run rapid and 5% for the first time proofing out a part. Once the part is proofed and we make sure our G-code is running properly, then we can move it up to rapid speed 100%. The first time we run a part, or we call it proofing a part, we want to make sure that there's no issues in our G-code or any of our offsets that might crash our machine. So in that instance, we want to run our machine at a slower rate. So how I'm going to do that is I'm going to use the rapid modes right here. So whenever I'm proofing a program, I want to proof it out in 5% rapid. You're going to see the rapid change there, rapid 5%. Let me show you what 5% looks like with the spindle speed moving. I'm going to go back into my memory. I got my program loaded in here, and I'm going to hit the cycle start button. You can see the spindle's moving at a relatively slow speed. If I want to stop that, if I see an issue, I'm going to use the feed hold button. going to use the feed hold button over using the emergency stop, because the emergency stop kills power to the spindle and it kills power to the table, and what can happen is there can be some inertia left over, and if the spindle isn't cutting, it can stop and bind and hurt our tools. Using the feed stop, the feed hold button I should say, stops the movement of the machine but keeps the spindle spinning. That allows the opportunity to clear out any chips in case we get into a bind. It might save our tooling. So let me show you the difference between that and the rapid 100 speed movement. So I'm just going to go ahead and I'm going to handle jog my spindle back up to the top here so that we can see how fast this thing actually moves. So I'm going to move my rapid to 100 and I'm going to push the cycle start button. You can see that moved a lot quicker, and we have a lot less time to fix a problem if a problem occurs. So anytime that we're using or proofing out a part, we're doing it for the first time, we haven't tested it out, we want to use the rapid 5% so that it gives us time to stop it.